take a quick look at equivalent fractions. The equivalent fractions. Now, if you remember what equivalent means equal, right? Equivalent is a very important vocabulary in this situation. Equal. It doesn't mean the same. It just means that they're equal to one another, right? So in this case, now, and let me explain what that means. Of course, you could say something like 1/2 equals 1/2 because they're the same. So these are exactly the same. Equivalent doesn't mean that they're exactly the same, but it does mean that they can be the same. Now let me explain it, because that sounds a little bit confusing, but it's less confusing than it seems once you actually start digging into it. Okay, remember what I said? When in doubt, draw it out. So in this case, as you know, I do like to use pizzas for my examples. So let's talk about pizza. Let's draw out a couple pizzas, okay? So let's say I have two pizzas. They are the exact same whole, okay? So these two right here, same size. We're going to say same whole in this case, okay? And you're going to cut them. We'll cut them both in half first. And then this one I'm actually going to cut into 4 pieces, into 4ths, okay? So let's say I came to you and I said, all right, I'm going to give you a whole half of this pizza. And then I, out of this other pizza, I'm going to take 2 fourths. Which one of us would be getting the better deal? Well, look at the picture. They're exactly the same, aren't they? That means, if you're looking at this picture, same size, same whole, these pizzas are the same, okay? These pizzas are the same. That means that 1/2 equals 2 fourths, right? Those are equivalent fractions. So they don't look the same. They don't look the same when you look at them as numbers, right? But when you draw it out like this, they actually do look the same. You can tell that they're equivalent, right? They're equal, okay? So this also applies, now it gets a little bit more confusing, because what if I said that this other pizza, let's say we drew 2 more pizzas, and what if this time we're going to draw 2 more pizzas, and what if this time this pizza is about this big, and this pizza is about this big, okay? This is like a size small pizza over here, and I cut it in half, and this pizza over here, size large, I cut it into 2 fourths again, okay? And this time I ate half of this one, and this time I gave you 2 gigantic slices from this one. Well, you have the same fractions, right? This is still 1/2 over here, and this is still 2 fourths. Now, they're not the same size, right? The pizzas are not the same size. However, the fractions, 1/2 and 2 fourths, are still equivalent. But this is where you have to watch out, because you might see problems, especially word problems. They say something like, well, Jeremy ate half of a small pizza. Jose ate 2 fourths of a large pizza. Who ate more pizza? Well, in that case, they ate the same. They ate an equivalent amount in terms of how it looks as a fraction. But Jose actually ate more because he ate a large pizza, right? He ate half of a large pizza, whereas Jeremy only ate half of a small pizza, okay? Don't get too caught up in those, but don't get fooled by them when you see them, especially, again, in word problems, okay? Now, sometimes you'll see something like this. Again, a half is a benchmark fraction, so it's a really common fraction, and you're going to see it really frequently. You'll see a fourth a lot as well. But a half is a really good one to always remember, okay? And it really means literally 1/2, right? So anything that's equivalent to 1/2, let's start with these, because anything that's equivalent to 1/2 has a pattern. So let's say we start with 1/2 over here, okay? Now we've already determined that 2 fourths is equivalent. But we can keep going, right? We can find a lot of other equivalent fractions to 1/2. We would use a comma to make a series, right? So 1/2 is 1. 2 fourths is 1, because 2 fourths equals 1/2, right? But there's another way to look at this. Okay, so what we did here besides drawing it out, like I said, when in doubt, draw it out. Besides drawing it out, there's another way that we can tell that this works, right? Because we found, or we can find, what we call a common factor. Okay? In this case, what we'd actually probably want to do is find the greatest common factor. And what I mean by that is, remember what a factor is. A factor is a number in a multiplication problem, right? It is one of the numbers in a multiplication equation. So in this case, we would want to figure out, okay, how can you get from 1 to 2, and how can you get from 2 to 4? And the other principle, the thing you need to remember here, is whatever you do to the denominator, you have to do to your numerator as well. Okay? So in this case, well, okay, we know that 2 times 2 equals 4. Well, that means that at the top, we also have to do a 2. We have to multiply the top and the bottom by the same number. And we're looking for a common factor. Well, we just found one. 2 is our common factor because 1 times 2 equals 2, 2 times 2 equals 4. Okay? Another pattern here, because they're all 1/2, because every number that we're about to look at is equivalent to 1/2. Another pattern here, which is kind of a fun one to look at, is this, the relationship between 2 and 4. 2 is half of 4. So if your numerator is half of your denominator, right? If your, I'm going to put n, is half of your denominator, then 1/2 is an equivalent fraction. Okay? All right, the bad handwriting. I get judged all the time by third graders with better handwriting. Okay? So, if your numerator is half of your denominator, then 1/2 is an equivalent fraction to that fraction. Okay? So let's look at it again. So let's draw it out since I wrote all over that part. Okay, so let's switch back here to a different color. So let's start again. We've got 1/2. We know that 1/2 equals 2/4. Now let's continue here. So another number, let's think of something else that we could put in here. Now again, like I said, when in doubt, draw it out. If you need to draw it out to figure out something that might equal it, do it. Let's do a quick example right here. Here's 1/2, right? Let's take another one. Let's say we cut it into thirds. Okay. Well, that might not be that helpful, right? Because there's nothing that we can do that's going to work there, right? 1/3 is not going to be equal to 1/2. 2/3 isn't going to be equal to 1/2. 3/3 is going to be 1 whole, right? Okay, so let's say instead we took a look at it and we said, okay, let's cut this into, now we have 1, 2, 3, 4, 5, 6. Now we just cut it into sixths, okay? Now what if I took 3 parts out of that 6? I took 3 pieces of that pizza. Well, hey, look at this. Those look exactly the same, don't they? Which means that this is 3 out of 6. 3 out of 6. Which means that 3/6 would be next in line here. Because 3/6 is also equivalent to 1/2. Okay? And how do I know that? Well, let's take a look at how we know that. Because not only do we know it based on the fact that 3 is half of 6, right? 3 divided by 2 is 6. 6 divided by 2 is 3, and 3 times 2 is 6, right? Or 3 plus 3 is 6. And remember, anytime you're multiplying by 2, you're looking at doubles, right? So not only is 3 half of 6, there's another way we can look at it, right? We can look at this one. 1/2 equals 3/6 because we can find a common factor. So in this case, we know, based on looking at it, we actually just said this. I just said it, right? 2 times 3 equals 6. Now again, I can do the same thing to the numerator, right? Well, good news is 1 times 3 equals 3. So 1 times 3 equals 3, 2 times 3 equals 6. We found a common factor. These are equivalent fractions. And the pattern continues that way, right? We continue moving in that direction. Now, if we were to continue looking for fractions that are equivalent to 1/2, and again, 1/2 is probably the easiest one that you're going to see, in my opinion, because we're continuing to look for, you're going to see another pattern emerging as well. I'll show you that in just a second. But you're continuing to look for things that say if you draw them out like pizzas, they're going to look just like 1/2. Okay? And you're also going to see that the numerator is half of the denominator. And again, if your numerator is half of your denominator, then 1/2 is an equivalent fraction. Okay? So, that's supposed to be right there. Then 1/2 is an equivalent fraction. So, well, let's try another one. Okay, once again, you got our pizza, 1/2 right here. Let's try it out. Okay, this time we already know that 2/4 works, right? And let's cut it into eighths. We have 8 parts there now. Well, let's go ahead and make it look like they're half gone. We're going to give away 4 pieces of pizza, and that becomes 4 eighths. And that means that 4 eighths is our next fraction in line here, because 4 eighths is also equivalent to 1/2. How do we know? Well, there are a couple different ways that we know, right? Because 4 is half of 8. That's the first way we know. And then the other way that we know is by doing the same thing that we did here, looking for a common factor. And in this case, again, we're trying to figure out what number can we use that works for both of these to get the 1 to 4 and the 2 to 8. What can we multiply by 1 to get to 4? What can we multiply by 2 to get to 8? And the number has to be the same, right? So, well, we know that 2 times 4 equals 8, which means that 1 times 4, according to the identity property, right? Any factor multiplied by 1, well, the product is that factor, right? So 1 times 4 equals 4, 2 times 4 equals 8. We have an equivalent fraction. We just found the next one, right? And we could keep going. 1/2 is, this works for anything that's equivalent to 1/2, okay? So even if I said, even if we moved down further down the line and I said 25 50ths, that's 25 over 50. I'm not going to draw it out because that'd be a lot of slices of pizza. And it better be a huge pizza or you're not going to get a very big slice, right? So 25 50ths. But here's how we know that 25 50ths is equivalent to 1/2. Well, because we know, just by looking at it, that 25 is half of 50. Which also means that, if we were going to follow the other pattern, right, 1/2 equals 25 50ths. We're looking for the greatest common factor between them. Well, 2 times what is going to equal 50? Well, we already know. We already know because we already determined that 25 is half of 50, which means that we said 50 divided by 2 equals 25, or 25 times 2 equals 50, right? That means that 2 times 25, and remember, that's the commutative property. It doesn't matter if I say 2 times 25 or 25 times 2. Either way, it's still going to equal 50. So 2 times 25 is 50. 1 times 25 is 25. We have another equivalent fraction. Now, if you look at these 1/2s up here, here's the other pattern that you're going to notice. Look at your denominators, okay? And this would continue going in this direction, okay? I just drew that line there to tell you that I was doing some gigantic fraction, okay? But look at this pattern here. Here we are in our denominators counting by 2s. We'll skip counting by 2s. 2, 4, 6, 8. We would keep going. 10, 12, 14, 16, 18. We would continue on, in this case, all the way up to 50. Okay? We could go all the way up. And look at our numerators. 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we would continue going. We would just keep going. Okay? So there's a pattern. You're counting by 1s on the top, 2s on the bottom. That works for any fraction equivalent to 1/2. Okay? Now, there are patterns for other fractions as well. Now, like I said, I'm telling you right now that halves are your easiest. That is the easiest fraction to find equivalent fractions, okay? That would be 1/2. Well, let's say you had something else. What if I was asking you to find equivalent fractions to something entirely different that wasn't 1/2? What if I was asking you to find equivalent fractions to 1/3? This is a completely different story, right? Because you can't, now we're not looking for halves. You're not going to look for your numerator to equal half of your denominator. You want your numerator to be 1/3 of your denominator, right? And there are a couple of different ways to figure this out, right? Well, of course, we can draw it out. We'll draw out a couple different ones. Okay? So first, let's cut this one into thirds, and I know we all have trouble drawing thirds that look equal, and that one doesn't look great, but still, we're going to get the idea here, right? And then we're going to cut this one out further into sixths. And we're going to figure out, well, what would be equal to 1/3? There's 1/3. Okay, that's 1/3. Well, what can I color in to make that look the same? Oh, check it out. How about 2/6? Would that work? Could we do that? Can we find, remember, the greatest common factor to make 2/6 work here? How can we get from 3 to 6 and 1 to 2 using the same factor, multiplying by the same factor to get both of those numbers where they need to be? Well, let's take a look and see what we can. 3 times 2 equals 6, and 1 times 2 equals 2. Oh, check it out. We just found it. We found the greatest common factor. We found a common factor. So we figured out that not only were our eyes right when we saw that 1/3 looks like 2/6, it actually works. 1/3 does equal 2/6. Now, if we were to continue, we would notice that there's a different sort of pattern here, right? Some of you guys are probably already noticing that there's a pattern going on here. Well, let's take a look at the next one. What else can we do? Can we cut this up even further? Could we draw out another pizza and make it even crazier? I think we probably could, right? Now we go 1, 2, 3, 4, 5, 6. Now we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12. We could have done 9 as well, right? But we have 12 right there. So we could figure that one out. I think we could probably pretty easily figure that one out, right? We would go like this. Well, does that work? 3 12s? Does that look the same? Or would be 4 12s? Does 4 12s look the same there? Well, let's find out. Let's find out if we can find a common factor between 3 and 12 and 1 and 4. What can we do? Well, looking at it right now, I think we know. I think if you look at those numbers, 4 and 12, you can figure out, wait a minute, 4 times 3 equals 12, or 3 times 4 equals 12. And of course, 1 times 4, you have to do the same thing that you do to the denominator, you have to do it to the numerator, right? 3 times 4 equals 12, 1 times 4 equals 4. That means we have an equivalent fraction. So we know that, in that case, 4 12ths is also equivalent to 1/3. But it looks to me like we missed something, right? And I'm going to show you what it is. Then we're going to talk about what that pattern is right there, right? So you'll notice again, we have something interesting going on here. We are counting by 3s. When we did 1/2, we were skip counting by 2s. Now that we're using thirds, we're going to skip count by 3s. So we would go like this. 3, 6, 9, 12, right? And again, on the top, we're actually just going up by 1 each time because we have 1 as a denominator. So it's 1, 2, 3, 4. And then we would keep going. So then we would keep going to our next one, right? And there's another pattern right here we'll talk about here. So we would go on our next one. 5, 15, and then 6, 18, right? And then on from there. Now, what you'll notice though is the relationship here between the numerator and the denominator when we're talking about thirds is that each one of these, if you can find a factor that works here, right? So check this out. Third is the one we started with, right? Third is what we started with right here, that 3. So look what we have here. Use a different color to make this a little bit easier to see. 2 times 3 equals 6. 3 times 3 equals 9. 4 times 3 equals 12. 5 times 3, right, equals 15. I guess we should go that way, huh? Right? 6 times 3 equals 18. So you've got a pattern there. So in this case, it really is the same pattern that we were working with before. It's just got the, one higher, right? Because instead of 1/2 or 1/2, 1 out of 2 parts, we're looking at 1/3 or 1 out of 3 parts. Okay, so this time we're skip counting by threes. And obviously, I'm sure you've guessed this, if we were to move on and say, well, what's equivalent to 1/4, we would be doing the same thing. Now we're going to skip count by fours, right? And since we're doing 1 as our numerator, 1 part out of the other. Remember, the numerator is how many parts are represented. The denominator is how many parts are in your whole, okay? It's important to remember that. Numerator is on top, it's how many parts are represented. Denominator is on the bottom, it's how many parts you have in the whole, in total, okay? So this means we've got 4 parts out of the whole, 1 part represented. We would keep going. We're going to keep going. So then we have 1, 2, we have 3, 4, 5. We would keep going with those numerators, right? Now on the bottom, again, like I said, we would skip count by 4. So we go 4, 8, 12, 16, 20. And again, there's a relationship here. I'm sure some of you guys are already seeing this. You're picking it out. Not only, of course, can you find common factors, 100%. There are common factors. That's how we know that fractions are indeed equivalent, is that there are common factors. And as an example, we find one right here. Because we know that 4 times 2 equals 8, right? And 1 times 2 equals 2. So our common factor in this case, and how we know these are equivalent, is the 2, okay? But here's that other pattern. Remember I said there is another pattern, another way that you could look at this, okay? In this case, every single one of them, 2 times 4 equals 8. 3 times 4 equals 12, right? 4 times 4 equals 16. 5 times 4 equals 20. Every single one of them. There's a pattern. And again, on the bottom with the denominator, we're skip counting by fours. This would keep going. 1/5. 1/5 is another one, right? And those are really not that hard when you look for equivalence there, because most of you have an easy time skip counting by fives, right? We got 2, or 3, 4, 5. And like I said, you can keep going, obviously. I'm just giving you a few examples. But 5, 10, 15, 20, 25. Right? So that means that 1/5 is equal to 2/10, 3/15, 4/20, and 5/25. And again, the way you can always double check, besides being able to skip count like we just did, the other way that you can always double check is to make sure that you can find a common factor. So let's look at 5/25. Well, we know in this case, we should be able to look at it. 5 times 5 equals 25, right? So in this case, we would say, okay, well, then we know we can use 5 as our common factor. 5 times 5 equals 25. 1 times 5 equals 5. Make sense? Here's another thing. Take a look at this one. This is an interesting pattern, and one that's really nice to use. It actually works with our others as well. It works with our 1/4. It works with our 1/5. 5, right here. 5. Excuse me, let me do that the other way around. 25 divided by 5 equals 5. So you take this one, divide it by that numerator, divide your denominator by your numerator. Remember, you always need to divide the larger number by the smaller number, right? So in this case, it would be 25 divided by 5, okay? Denominator divided by numerator. 20 divided by 4 equals 5, right? 15 divided by 3 equals 5. 10 divided by 2 equals 5. Okay? Every single one of those will equal 5 because we're looking for 1/5. Every single one of those is part of something equivalent to 1/5, right? They're all equivalent to 1/5. Every single one of these fractions.